lesson is 37, areas of combined polygons. What's our objective, class? Get ready?
Areas of combined polygons.
Good. So we're going to learn how to take rectangles and triangles or irregular shapes and divide them into shapes that we know how to take the area of and calculate the area. So why does this lesson, how does this lesson apply to our lives? I'm going to show you a slide. Let me pull it up. And this is a piece of property. Right here, I'm going to have Kaylee, if you'll hit zone 4 on the light switch, just hit the number 4. So this is actually where I live. This is a 5-acre lot, and we've got all this nice space. And 2 summers ago, we laid sod. So I'm going to explain to you how laying sod applies to today's lesson. So I'm going to zoom into my yard. Sod is that nice, lush green. It's not that green anymore. So what we had to do is we had to call the sod company and say, hey, we need some sod delivered. And do you think we said, probably need like 7,000 or maybe 8,000 square feet of sod? No way, because sod's expensive. We had to calculate exactly how much sod because they bring it on these little pallets. They drive around and they see all the little driving marks because they dropped them off. Pallets all the way around, and it takes hours. Like it took us 2 days to lay all the sod, and it cost over $2,000. So we wanted to make sure we were accurate in our calculations because if you order too much sod, they'll drop off the sod and it's yours. And then you have no sprinklers out here, and so you can't do anything with this sod if it's extra. It's wasted money. It's like a $500 bill thrown away. So you want to make sure you order the exact amount of sod. So how did we do combined areas of polygons? So look, I took a little rectangle here. I took a little wider rectangle here. I measured this rectangle here. This was 60 by 120. These were a little smaller. And then look at this one. It was actually curved. I thought, I'm going to just make a triangle out of it. I took a rectangle here. This is all flower bed right there, just dirt. And then I think what I did here, I know I sectioned this off, and I probably did about like this. Probably a triangle part right there, and it actually goes square or rectangular there. A triangle right here. So even though it's curved, I figured, if I triangulated it about there, I'd come pretty close. And maybe where I lost it there, I had extra here. I squared that off. Maybe I did this. So I went through my whole yard and I calculated length, width, length, width, length, width. I probably did that. Length, width, maybe a little triangle piece right there. I came within, I was pretty much right on the mark. I think I calculated 9,600 square feet of sod. Well, my husband's an engineer. He's really smart at math, and he calculated 9,200 square feet of sod. And I said, well, you're the man of the house. That's okay. Maybe I made a mistake. We went with the 9,200, and guess where we ran out of sod? About right there. So my calculation was actually right. I did it right because I was really careful on every little shape by partitioning it up into shapes I knew how to do, triangles and rectangles, and I came right on. So we laid to about here, my husband and my kids. We did all of this up to here, and then the young men showed up and they did this whole backyard in like less than an hour. It was awesome. So when it comes to a shape like this, this seems like so much simpler now, right? All we have is a rectangle and a triangle. So we're going to do that. We're going to take this rectangle and a triangle and figure out the area of each. So the rectangle is 6 by 4 or 24 centimeters squared. The triangle, we need a base and a height. We have the height, that's 4. We don't have the base, we need to figure that out. Take your whole length, 8. We know this much is 6, so subtract 8 minus 6. What's our base? Get ready?
2 centimeters.
Area of a triangle, oh, thank you, that's 2 centimeters. Area of a triangle is 1/2 base times height. What's the area of a triangle? Get ready?
1/2 base times height.
Good, 1/2 base times height. So I'm going to take 1/2 of my base is 2. My height is 4. I go 1/2 of 8, which is 4 centimeters squared. Now look, be careful. I had my rectangle and I had my triangle. I want the total sum of the areas, so I add them. I don't multiply them. I have students that sometimes try to multiply, thinking it's like a length and width. It's not. It's this area plus this area. 24 plus 4 is how many centimeters? Get ready?
28 centimeters squared.
Good. I forgot the square. 28 centimeters squared. Good. I'm going to have Kaylee, I want you to hit the lights off and then back on so that we can get more bright, so it's not so dark to you and super blinding to me. 2 more examples. Here's another one of our Jawa transport machines. This one takes it up a notch of complexity because if I partition it here, I need to do this triangle, but I don't have that leg right there. I do have this one at 100, but I don't have this one. Hey, wait a minute. Do I have a right triangle? Can I use Pythagorean's theorem to find the missing side of my right triangle? Yeah. So I'm going to just, I don't need to redraw the triangle. I'm going to start with my formula. Pythagorean theorem starts with a squared. What is it? Get ready?
A squared plus b squared equals c squared.
Very good. A squared, we'll call this one A. I don't know it, but I do know B squared. It'd be 100 squared. C squared would be 110 squared. I'm going to need someone with a calculator real quick, so get your calculator out. A squared plus 100 squared is going to be 1 with 4 zeros. And I need 110 squared, if I remember from my last class, 12,100, but check it just to be sure. That's right. Thank you, Ethan. Okay, to solve for A squared, remember I got to subtract the other leg from the hypotenuse. That's going to leave me with 2,100. Now to find A, I take the square root of both sides. I only want the principal square root or the positive square root. What do I get? Whoever's got that. Lexi.
I think it's 45.8.
You're right.
So
You're right, 45.8. So this, does it look about right? It looks about right. Since we get to estimate, I'm going to take the liberty and I'm going to round this to a nice easy number. I'm going to call it 50. Now we can find the area. We've got length times width, so 100 times 60. Can we just take the 60 and add 2 zeros? We're going to do that. Feet squared. How about this triangle? Let's go, I'm going to write right here. Area of a triangle is 1/2 base times height. What's the area of a triangle? Get ready?
1/2 base times height.
Good. So base is 50. We round it to 50. Our height is 100. So 50 times 100 is a 5 with 3 zeros. 1, 2, 3. And half of that is going to be 2,500. Throw our units on feet squared. 2,500 feet squared. And now I need that plus that for a total of, can you see the 2 plus 6 is 8, and then the 500. I know I did that a little bit fast. But that's our combined area. So we had to do Pythagoreans. We had to do the area of a triangle, area of a rectangle, and add them together. But it's kind of cool. It took us up a level. Could you do this in your head? No. So when you're doing these, should you draw, label, draw steps, square root, calculate, write your formula, don't forget your 1/2? Yeah, it takes more steps. You're in course 3 now, it takes a little bit more writing. The next step, I want you to practice writing. I'd like you to draw this triangle on your notes. Look up at me when you are finished drawing and labeling your triangle. Make it big, because we're going to be putting all kinds of distances on the triangle. All right, so let's continue. I'm going to blow it up so we can work with it a little bit more. Oh, before I blow it up, I can't blow it up because we got to read the instructions. What do we know about this triangle? First of all, we know that AD is 40 centimeters. AD is 40. We know B, sorry, I got to put that down. That's a D, right? DC is 30. Oh, I'm going to pause there. Wait a minute. If I have a triangle that's 40, 30, something comes to my mind, and it's remembering something about a 3 and a 4. There's a Pythagorean triple in there. What's my missing number? Winry.
5.
It's a 5. So the triple is 3, 4, 5. What's the triple? Get ready.
3, 4, 5.
3, 4, 5. That's your common triple. So if I see 30, 40, that works here too. 30, 40, 50. So AC must be 50. Are we in centimeters? Centimeters. Okay, let's keep reading. It says B is the midpoint of AC. If B is the midpoint, it means it cuts it in half. So that is half of 50, and this side is half of 50. It says E is the midpoint of AD. So E cuts this leg in half. So half of 40 is 20. Half of 40 is 20. Do you think this smaller triangle is similar to the bigger triangle? Remember our rule on similarity we learned last week? It was, if sides are proportional, the triangles are similar. Do we see a proportionality of sides? This is half of this. This is half of this. Same angle, same angle, same angle, same angle, right? They're proportionate. Therefore, could I say if this is 30, this one is also half of 30? Okay, good. What is half of 30? Okay, ready?
15.
15. Now I know tons of information about my triangle. So what is it asking? Find the perimeter and the area of the BCDE. BCDE is here. I drew it in the wrong order, but it's the same set of triangle. Quadrilateral. Okay, perimeter. Let's put it inside. Perimeter equals the sum of all of the edges, 15, 25, 30, and 20. 5 plus 5 is 10. 1 plus 2 plus 1 is 4, plus 3 is 7, plus 2 is 9. So we're 90 centimeters for the perimeter. What about for my area? I'm thinking, oh man, I'd have to divide that into a triangle, or maybe could we use another method to find this area? And it's kind of a cutout from a bigger triangle. Does anyone see a way we could maybe use the bigger triangle to help us, Colin?
You find the area of the bigger triangle, and then you subtract the area of ABB.
So we could use the subtracted method. I love what Colin said. He says find the area of the bigger triangle and subtract off the smaller triangle. Cool. So let's do two areas. We need area of the big and area of the small. Area of the big is 1/2 base times height. What's the area of a triangle? Get ready?
1/2 base times height.
Good. 1/2. The base of my big triangle is 30. The height is 40. 1/2 of 30 times 40. Well, 30 times 40 is going to be a 12 with 2 zeros. Half of that is 600 centimeters squared. Let's circle that because we're going to come back to that. Now, the area of the smaller one, we need our 1/2 base times height. Our base is 15. I'm going to rewrite that so you can see it. 15. Our height is 20. We're going to take half of 15 times 20. What's 15 times 20? Bo.
15 times 20, hold on, let me do that.
Try just 15 times 2.
And that's 30.
Good. Add 0.
150.
300. Okay, good. What's half of 300, Bo?
150.
Perfect. I love it. There's a lot of cool mental math tricks. Okay, so 150 centimeters squared. So the big one is 600. The small one is 150. Do you see how we could subtract off the small one and it would leave us with this piece? So we're going to take it out here. 600 minus 150. That gives us 450 centimeters squared. So that's the subtractive method. Is it weird? Someone said, isn't this half the size of the big one? So shouldn't the area be half? The area was definitely not half. It was like a fourth of the big one. So really I could fit 4 of those triangles in there. We'll have another lesson on that. Okay, that's it. So we're on page 247. Your problems are A and C. 20 seconds, stand up break.